Hello and welcome. My name is Tokebi Games. I am a former Roblox engineer and I will be teaching you how to develop game mechanics. In the previous video, I showed you how to sell your loot and turn your hard-earned items into useful resources. In this video, we're shifting gears and diving into something more peaceful, learning how to grow your own garden. Whether you're planting for survival, aesthetics, or crafting, I'll walk you through everything you need to get started and make your garden thrive. To start building this system, we'll continue from our previous project. First, let's create two new remote events inside the appropriate folder in replicated storage. These events will handle two main actions. One will trigger the planting menu to appear, and the other will be responsible for placing the selected seed onto the plant bed. Next, we'll create a new folder called Plants Inside Server Storage. In this folder, we'll place two models, one representing the plant in its early growth stage, and another for when it has fully matured. Now, inside the matured plant model, we'll add the same tags used by the wheat plant in the workspace. These tags are important because they let us reuse the harvesting system we built earlier, allowing the plant to be harvested once it's fully grown. So if you haven't watched the previous tutorial, now's a good time to check it out before moving on. Before we start scripting on the server side, we need to tag the ground part of the plant bed model with planter. This will allow us to easily identify all planter objects in the game and add functionality to them later. Lastly, we'll add a new item under the loot folder called wheat seed. This gives us a way to provide the player with a plantable item. You could also implement this through a store system if you prefer. In the new wheat seed loot, make sure to add the tag planter along with the necessary attributes. I'm still adding attributes directly to the loot object for now since I haven't set up a configuration file yet. But feel free to try that approach yourself, as I've already shown how to do it in a previous tutorial. Now we need to add a new configuration file under the Configuration Files folder inside replicated storage. We'll name this file Plants Config. In this script, we'll define the wheat seed we added to the loot inventory, including its growing time and a reference to its sprout model. We'll also define the young plant model with similar properties. Notice that the keys for each item use the exact same names as the physical models, and the sprout property specifically references the physical model for the plant's next growth stage. This setup makes it easy to clone the correct model when advancing the plant to its next stage. Also, note that the matured plant is not included here because it is tagged as minable and will be handled separately by the minables config, since it does not grow any further. Now under Server Script Service, let's create a new script called Planters. This script will use Collection Service to select the plant beds from the workspace and add the necessary functionality to enable planting seeds. At the top of the script, we'll set up our imports and variables. We begin by importing Collection Service. Then we gather all objects tagged as planter and plantable. Next, we reference the remote events we created at the start of the tutorial. Finally, we import the plant's config configuration file. Next, we'll create a function that clones the object we want to place in the planter. Notice that we add an attribute called plantedAt to record the time the seed or plant was placed. This helps us track how long it has been growing and when to advance it to the next stage. Also, the Y position is calculated by adding half of the plant's size in Y to the planter's position. This ensures the plant always sits right on top of the planter's ground. Next, we'll create a function called ActivateClickDetector, which adds functionality to the click detector inside each planter. If I haven't mentioned it earlier, make sure each planter model has a click detector. We start by looping through all planters collected using Collection Service. For each planter, we look for its click detector, and if it exists, we connect a function that runs when the planter is clicked. Inside this function, we create a table called MyPlantables, where we'll store the plantable items that the player currently owns. We go through the full list of defined plantables and check if any of them are in the player's inventory. If a match is found, we add it to the MyPlantables table. Once we've filtered out valid items, we check that the planter is not already seeded, meaning it doesn't have a plant yet. If it's empty and the player owns one or more plantables, we trigger the Show Plant Menu remote event. This opens the planting menu on the client side. We pass two pieces of information. the My Plantables data, and the specific planter clicked. This is needed because the planting interface is shared and must know exactly where to place the plant when the player chooses one. Next, we'll create a local function called plantSeed, which will be triggered from the client when the player chooses to plant a seed. This function takes two arguments: the plant the player wants to plant and the planter where it should go. First, it checks that the specified plant exists in the player's inventory and that the target planter is not already seeded, meaning nothing has been planted in it yet. If both checks pass, we subtract 1 from the player's seed count, and if the count reaches 0, we remove the seed entirely from their inventory. Then, for added safety, we check that the plant is part of the player's valid plantables and that the planter is still unseeded. If everything looks good, we mark the planter as seeded and call the cloning function we defined earlier to spawn the plant in the game world. Lastly, outside of the click detector function, we define a new function called growPlants. This function is responsible for managing the growth of plants placed in the planters. We use run service here because we need a continuous loop to monitor growth. Inside the loop, we go through all the planters and check their children, since the planted model was parented to the planter. If the child's name matches one in our plant configuration list, we retrieve the plant's properties like grow time and sprout. This is where the planted at attribute becomes useful. We subtract the planted at time from the current time to calculate how much time has passed. If that time exceeds the defined growth time, we destroy the current plant model in the planter and call our clone plant function with the sprout model. That's why earlier we made sure the sprout field in the config references the next stage model directly. Now in our minable script, we need to refactor some code for better reusability. Start by taking the logic inside the addAttributes functions for loop and moving it into its own function called itemAttributes. Do the same with the addEvent function, extract its logic into a standalone function. Then, create a new function called assigner, which will be called whenever a new minable item is added through the collection service. This ensures that when a plant reaches full maturity, it will be correctly recognized as a minable and automatically receive its properties from the minable's configuration file. Lastly, on the client side, we'll clone our cell loot GUI and make a few modifications. Rename it to planter GUI and update the script accordingly as shown in the image. Once you've done that, your plant growing system is complete. You now have a fully functional mechanic where players can plant, grow, and eventually harvest crops, all integrated with the systems we built in previous tutorials. And now it's time to test our system. Start by clicking on each planter and selecting Plant from the interface. Do this for all 4 planters. You'll notice that the plants begin to grow immediately after planting. Once they've fully matured, equip your sickle and harvest them. You'll see that they yield the same resources as the original wheat placed in the workspace. This happens because both use the same configuration file, keeping everything consistent and easy to manage.
You can have access to this file by following the link in the description to my GitHub repository. Also, please join my community on Roblox, Tokebi Academy, where you can have access to the demos and collaborate with me. If you have not done it yet, please take a minute to subscribe and like this video, as this will greatly help me to continue making this type of content. Thanks for watching, and hope to see your comments and suggestions.